All right, and welcome to our last topic for nomenclature. I'm sure you're excited already. This topic is actually brand new, and it's all about naming acids. So you might have come across some of the names of acids before in grade 9 and grade 10 chemistry, but you've never actually been shown how to name them. So we're going to name two different types of acids today. The first type of acid we're going to name is called a binary acid. So a binary acid, binary actually just means two, bi means two. So a binary acid is formed when hydrogen is going to combine with some sort of other nonmetal. So we know it's an acid because it's got hydrogen in it. We learned that in grade 10. So all acids start with hydrogen, and hydrogen is bound to some sort of other nonmetal. The other thing to make it an acid, acids are actually always dissolved in water. So acids always have the symbol aqueous with them. That's the state. So acids are always dissolved in water. They're always going to be aqueous. There's two different ways to name acids. The first way to name acids is using IUPAC. So that's actually what we've been doing so far with our nomenclature, is we've been using IUPAC to actually name things. However, the IUPAC names for acids are a little bit longer. So acids also have what's called a classical naming system. What that classical naming system is it's just a way that chemists will go through and name acids. So you're actually probably more familiar with the classical naming system. Terms like hydrochloric acid, that's an example of a classical name. So I'm actually going to teach you both. I'm going to teach you the way according to IUPAC how to do it, and I'm going to teach you the way that you're probably going to see it in a chemistry lab if you go on to study chemistry. So let's start with the one that I find easier, and that's actually IUPAC. So the IUPAC name for the acid is an acid that is simply the standard IUPAC name preceded by aqueous. So let's take a look at this and ask ourselves how we know it's an acid. I know it's an acid for two reasons. It's got a hydrogen in it, it starts with hydrogen, and it's got that aqueous there. So now that I know it's an acid, I'm going to go ahead and I'm going to give it its IUPAC name. So I actually am going to start with a state, and I'm going to use the word aqueous. We again only do this for acids. And then in this case, I just name it like I would a regular binary compound. So something that contains hydrogen and starts with hydrogen, we actually name as an ionic compound. So we would name this hydrogen. There we go. And we would name this fluor. And then it ends in "ide," right? So you always have that "ide" ending. So I would go ahead and I would call this aqueous hydrogen fluoride. So this IUPAC name would be aqueous hydrogen fluoride. All right, I'm going to try the same for the next one. So again, how do I know it's an acid? It starts with an H, and it's got that aqueous behind it. So I'm going to go ahead and I'm going to start with the word aqueous. We can see oh, that's not aqueous. I'm going to start with that word aqueous. Struggling today. And then I'm going to follow it up by that hydrogen. Now, next up, CN. Hopefully you have enough experience with compounds now that you're not going to try to tell me this is carbon nitride. You're going to recognize that this is a polyatomic ion. So it's a polyatomic ion. We have more than two atoms together. So I'm actually going to look up what this polyatomic ion is, and I'm going to find that CN stands for cyanide. So the name for this would be aqueous hydrogen cyanide. We can actually go in the opposite direction as well too. So I'm just going to switch screens so you can see me draw. There we go. And we're going to do aqueous hydrogen cyanide here. So aqueous hydrogen cyanide, we know it's an acid because it's got a hydrogen in it and it's got that term aqueous. So I'm going to start with an H. I know it's an acid. And I'm going to put that AQ over here. And now I'm going to proceed just like I would with a regular binary compound. So if I was writing the chemical formula for hydrogen sulfide, anytime I've got a hydrogen first, it acts like an ionic compound. So I have to consider charges. So hydrogen has a charge of +1. Sulfur has a charge of -2. So remember, these charges are actually going to cross over. So the 2 is going to be written next to the hydrogen, and we actually wouldn't write that 1. So if I was writing this, I would put the 2 from the sulfur next to the hydrogen. I'd put my S here, and the chemical formula for the acid aqueous hydrogen sulfide would be H2S and that little aqueous symbol there. So let's look at the classical naming system again. So we're going to look at the classical naming system, and this is more realistic of how you're going to see acids named. So the classical naming system has the structure of hydro, root, ic, acid. So essentially hydro is always going to be the same. Ic is always going to be the same. Acid is always going to be the same. The only thing that's going to change is this root. What this root is your nonmetal. So let's take a look at your HFAQ. So this is what we called aqueous hydrogen fluoride before, and let's see how we would actually name it. So again, the term hydro is always the same. I want a period there. And the ic is always the same. And acid is always the same. The only thing that varies is what goes in this gap here. And what goes in this gap is whatever this nonmetal is. Well, the nonmetal in this case is fluorine. So I'm going to go ahead and I'm going to call this fluoric acid. So just like I wouldn't call it fluorinide, we drop the I-N-E ending. So you're dropping your I-N-E ending just like you would, but instead of putting I, you're putting ic. So hydrofluoric acid. So why don't you go ahead, pause the video, and why don't you try the next one yourself? So again, for this, we're going to be using our classical naming system. So we're going to be using that hydro. We're going to be using that ic, we're going to be using that acid, and in here, I'm just going to put the root. So in this case, remember, it was cyanide. So I'm going to go ahead and I'm going to call this hydrocyanic acid. So rather than cyanide, it's cyanic. So hydrocyanic acid. Now, hydrosulfuric acid, how would you actually draw this? We're going to go to my drawing screen. How would you actually do this chemical formula? So again, I know it's an acid because it actually tells me it's an acid. So my acids always start with H. My acids always have that AQ. And this is acting like an ionic compound. So for this, I've got hydrogen, and my root here is sulfur. So hydrogen, again, has a charge of +1. Sulfur has a charge of -2, and we're going to go ahead and we're going to cross over those charges. So this 2 is going to go with hydrogen, and this 1 is going to go with sulfur. So I'm going to write H, I'm going to write 2, I'm going to write S, and how I would actually write the chemical formula for hydrosulfuric acid, H2SAQ. So next up, we are going to look at our second type of acid. So that was binary acids. We're going to take a look at what we call oxo acids. So I'm really hoping that you guessed that an oxo acid probably has oxygen in it. So oxo just stands for oxygen. So they're acids that contain oxygen. They're called oxo acids. They contain a hydrogen, they contain an oxygen, and at least one other element. So in this case, we're always going to be dealing with at least 3 atoms. One of them is going to be a hydrogen, one of them is going to be an oxygen, and the other is going to be some sort of other element. So the fact that we've got hydrogen bound to at least 2 elements means that we're going to be using a lot of polyatomic compounds. So essentially an oxo acid is something that's with a hydrogen and a polyatomic compound bound to it. Again, there's an IUPAC way and there's a classical way. The IUPAC name for oxo acids is the same naming rules for binary acids. So we're going to start with the word aqueous, we're going to put the word hydrogen, and we are going to put whatever follows it. So they're ionic compounds, so they're going to act just like we name ionic compounds, so aqueous hydrogen and whatever follows it. The classical naming system actually is going to depend on the ending and whether or not the ending is "ite" or whether or not the ending is "ate." So remember, you can have 2 different endings for polyatomic ions. The "ate" ending is the typical amount of oxygens. The "ite" ending means that there's 1 less oxygen than you would expect. If you have the "ate" ending, you're going to go ahead and use this structure. You're going to use the root ic acid. So notice that this is actually very similar to what we saw before. All we've done is we've dropped the word hydro. So rather than having hydro ic acid, we instead just have ic acid. So before you might have heard of the term hydrochloric acid. That's an example of a binary acid. An example of an oxo acid would be like sulfuric acid, right? So we have no hydro in front. We just have the root, the word ic, and the word acid. If an oxo acid ends in ite, so if it's got an ite ending, it's going to be almost the exact same thing. We're still not going to have a hydro, but instead of ic, we're going to have us. So we're going to have the root, whatever the root is, us, acid. So let's go ahead and let's look at this. And I've actually made this a little bit more challenging. I've shuffled these all together. Doesn't that sound like fun? So I've shuffled all of these together. And for all of these, we're actually going to go ahead and we are going to look at giving these a classical naming system. We're going to work on the classical naming system just because I think it's a little bit more challenging, right? The IUPAC is really easy. It's just aqueous and whatever it is. We're going to try the classical naming system for all of these. So first of all, we have to look at this first one, and we need to decide how do we know it's an acid. So I see a hydrogen in front, and I see an aqueous, so I do know it's an acid. Next up, I'm going to look and I'm going to see what's bound to my acid. Is there an oxygen? If there is, it's an oxo acid. So I see hydrogen, I see aqueous, I know it's an acid. I see oxygen, I know it's an oxo acid. Now I'm ready to go ahead and I'm ready to name. So I am going to name this. Now to name this, I need to go ahead and I need to take a look and see ClO3. That's a polyatomic ion. What's that polyatomic ion? So if I actually refer to my polyatomic ion chart, I'm going to see ClO3 is actually an example of chlorate. So chlorate is ClO3. Chlorate has an 8 ending. So we're going to use this structure here. We're going to use the root ic acid. So the root in this case is chlor. The ending is an 8 ending, so we're going to use ic space acid. So HClO3, we're going to have the classical naming system of chloric acid. Now what I'm going to do is I'm going to try the next one. I'll do the next one with you and then maybe try to pause the video and try a couple of these on your own. So again, how do I know this is an acid? I know it's an acid because it's got a hydrogen in front and it's got that aqueous. So I need to go ahead and I need to figure out what this polyatomic compound is. It's got an oxygen, so I know it's an oxo acid. And if I actually go ahead and look at my polyatomic chart, I'm going to find that ClO4 is an example of perchlorate. So it's got an 8 ending. Since it's got an 8 ending, I'm going to be using this structure here. So I'm going to use my root. My root in this case is perchlorate. So my root is perchlor. My ending, since it's an 8 ending, is going to be ic. And then acid. So the name for this would be perchloric acid. Okay, why don't we try to challenge yourselves? So I love to challenge ourselves. Why don't you pause the video and try to see if you can figure out what this one here is going to be. So hopefully you actually did it, right? If you got stuck, that's okay. So let's take a look at what this is going to be. Now we're actually writing out our compound. So I'm going to go to my writing screen. There it is. And we're actually going to look at writing out our compound. So now you just want to work backwards. I've got an ic acid. Since I've got an ic acid, I know I'm dealing with something up here, ic acid. So I know I've got an 8 ending. I know it's an acid. So since it's an acid, it's going to be H and it's going to be AQ. And I'm looking for a polyatomic compound that has a root of carbo and ends in 8. I'm really hoping you're going to figure out that that's carbonate. So in this case, we're looking at the polyatomic ion that's bound to carbonate. So carbonate, just to remind you, is CO3. And it's got a charge of 2 negative. Now remember, we do have to cross over our charges. So hydrogen has a charge of +1. Carbonate has a charge of -2, so we're going to go ahead and we are going to cross over those charges. So the charge of 1 is going to come next to carbonate, and the charge of 2 is going to come next to hydrogen. So we're going to bring a 2 here, and we don't have to write that 1, so I'm just going to include carbonate as it is, CO3. So carbonic acid, that's actually really common when we talk about acid rain, is going to be H2CO3, and it's going to be aqueous. All right, we are back to naming. So let's try the next one. So again, if you haven't paused the video yet, pause the video, see if you can figure it out. Hope you did it. So how do I know this is an acid? It's got an H in front, and it's got an aqueous behind it. So it's got an H in front. That means it's going to be an acid. So we can start with the name acid. Now ClO2, we have to figure out what polyatomic compound this is. And if you actually look up what polyatomic compound it is, it's going to be chlorite. So it's going to have that ite ending. Since it has an ite ending, we're going to use this structure, root, us, acid. So the root in this case is still going to be chlor, but in this case, rather than chloric, we're going to call it chlorous acid. So we're going to have that OUS because it's got an ite ending. So chlorous acid. What about this next one here? Well, it's still an acid because it's got hydrogen in it and it's aqueous. It's an oxoacid because it's bound to more than one thing, and one of those things is an oxygen. So now I just need to figure out what polyatomic compound this is. If I look at my polyatomic chart, I'm going to see that that's perchlorite. So it's got an ite ending. That means I'm going to be using my root, us, acid. So I'm going to go ahead, and my root in this case is going to be perchlor. And then my ending, since it's an ite ending, it's going to be us acid. So perchlorous acid would be Cl or HClO with that aqueous. Last up, let's work backwards. So we're going to work with nitrous acid. So I'm going to go to my screen that I can write on. Pointer. Ooh, let's erase this first. Give us a little bit of room. Hopefully this is giving you a chance to actually work it out on your own, right? I'm hoping you're trying it on your own. So nitrous acid, it says it's an acid. So since it's an acid, we know it starts with H, and we know that it's aqueous. We know that it's an oxoacid because there's no hydro. So we're looking at polyatomic compounds. So we're looking at a polyatomic compound that has the root for nitro, and it's got an us ending. An us ending means that it's an ite. So we're looking for nitroite. We're looking for nitrate. So this is an example of our polyatomic compound bound to nitrate. Now nitrate, if I look it up on my chart, is NO2. And it has a -1 charge. Well, hydrogen has a +1 charge. Nitrite has a -1 charge. So we're actually not going to see any charge switching. We're not going to see any crossing over rule because both the numbers are 1. So I can go ahead and I can just write nitrite here. And this is how I'd write the chemical formula for nitrous acid. All right, so that can be a little tricky to remember. So in order to remember it, there's a couple of different rules that you can, there's a couple of different kind of memory techniques that can help you here. So the term my ride has hydraulics. So what that helps you to remember that if there's an "ide" ending, it's going to have a hydroic acid. So anything that's a binary compound is going to have an "ide" ending in its name. So if it would normally have an "ide" ending, it's going to have that hydro in front of it. So for example, hydrogen chloride is going to be hydrochloric acid. Another example here, hydrogen bromide, aqueous hydrogen bromide is going to be hydrobromic acid. So anything that with the IUPAC name has an "ide" ending is going to have a hydro in front and an "ic" at the end. My ride has hydraulics. I ate something icky. So anything that ends in "ate" is going to have the "ic" acid root. So ends in "ic" acid root. So for example, aqueous hydrogen nitrate, it ends in "ate." I ate something icky, nitric acid. And the last one to help you remember, Sprite is delicious. I don't really like Sprite, but let's try to remember that Sprite is delicious. So anything that has an "ite" ending is going to end in the "us" acid. So for example, this would be aqueous hydrogen nitrite. So aqueous hydrogen nitrite, it's going to end up being nitrous acid. So I want you to try these on your own. So I want you to go ahead and I want you to do the classical name for all of these acids. I actually want you to do this. So pause the video and see if you can actually figure this out. All right, so I'm going to walk you through these. So let's walk you through naming these ones first. So in order to name them, first of all, I have to consider, is it an oxo acid or is it a binary acid? In this case, I've got an oxygen. It's an oxo acid, so you're not going to see that hydro up front. So now all I have to do is I have to determine, does this have an "ate" or an "ite" ending? This here is phosphate, so it's going to have that "ic" ending. So I'm going to call this, instead of having it be phosphate, I'm going to call it phosphoric, and then it's going to have that ending acid. So this is going to be an example of phosphoric acid. Now I'm going to take a look at this next one. This next one has no oxygen. That means it's an example of a binary acid. Since it's a binary acid, it's going to have that hydro in front. So it's a binary acid, so we're going to have that hydro in front, and we're going to follow that hydro by that root. In this case, the root is fluorine, so fluoro. And we always have that "ic" ending along with acid. So we would actually call this one hydrofluoric acid. Let's take a look at this next one here. So for this next one, let's move this up here first. There we go. So for this next one, I'm going to take a look and see, does this have an oxygen in it? It does. Since it has an oxygen in it, I know it's an example of an oxo acid. So I want to go ahead and see PO3. What ending does PO3 have? If you look this up, you're going to find that it's got an "ite" ending. This is phosphite. So this here would be same as before, phosphor, and instead of having an "ic", it's going to have an "is", right? It's got an "ite" ending. "Ite" has an "us" ending for acids, and we're going to call that acid. So this is going to be phosphorus acid. Down here, this is another example of a binary acid. We have no oxygen. So since it's a binary acid, it is going to start with that hydro. So we're going to call it hydro. And then we're going to put the root here. The root in this case, iodine is iodo. And then we've got that "ic" ending along with acid. So really weird word, hydroiodic acid, but that is technically correct. Next up, we've got another binary acid. We know it's a binary acid because we don't have any oxygen present. It's not an oxo acid. So we're going to call this hydrogen. We're going to call this hydro, and then we need to put the root here. So the root in this case is going to be bromo, and we're going to end with an "ic". So instead of having that O there, we're actually going to drop the O, and we're going to call this hydrobromic acid. So typically when we have two vowels that are together, you tend to drop the two vowels. The only exception is really iodine. So with iodine, you keep all the vowels. It looks really weird. Other than that, if you have two vowels together, you tend to drop the vowel and you put your "ic" ending instead. Here, we've actually done this one already, so I hope that you recognized it. I was trying to trick you. So this here is an example of a binary acid, right? I know that there's more than two things, but there's no oxygen present, so it's not an oxo acid. So since it's a binary acid, we're going to have the word hydro in front. And then we're going to put our root. Our root for CN, CN stands for cyanide, so we call this cyan. And instead of calling it cyanide, cyanic acid. So this is an example of hydrocyanic acid. And this last one here, HNO. HNO, we know this is an example of an oxo acid because it's got that O in there. So if I take a look at what NO is on the polyatomic chart, you actually find that it's hyponitrite. So hyponitrite. So we know it is an oxo acid, so we don't use hydro, but we do need to use hypo because that's part of the group. So hyponitrite, so we're going to call it nitra, and instead of calling it ite, anything with an ite has an us ending acid, hyponitrous acid. And then I'm sure you're wondering why there's a star. There's a star here because there was a challenge. So I really hope that you challenged yourself. And I hope that you found out that in this case, we are dealing with a polyatomic compound. So we are dealing with an oxo acid. We've got hydrogen and we've got it bound to an oxygen. Your polyatomic compound is here, and I'm really hoping you found out that was acetate. So this is how you represent the polyatomic compound acetate. So it is an oxo acid, no hydro necessary. We just need the root. The root here is acetate. So instead of calling it acetate, we call it acetic acid. Acetic acid, you've probably heard of it before. Vinegar, that's actually the chemical formula for vinegar. This is going to come back a lot in grade 12 chemistry because we use acetic acid a lot in unit 4. And this is actually going to come back a lot in unit 3 as well too when we talk about titrations. Now I want you to pause the video again, and I want you to write the formulas for all of these things. And when you come back, we'll go ahead and we'll take these up. So I'm going to go to my writing screen. Where's my writing screen? There it is. So we're going to go ahead and we're going to look at my writing screen. Actually, I can probably zoom in a little bit now. And we are going to look at naming these following formulas. So nitric acid. Since it's nitric acid, it's an acid. So I know it's got an H in it. Actually, let's switch out this color. Dark blue, is that better? That's better. So I know it's got an H in it. And I know it's got that aqueous, AQ. Now I just need to figure out what nitric is. It's got an ic ending, so I'm looking for the polyatomic compound that has an 8 ending that's got nitro as a root. Well, that's going to be nitrate. So nitrate is NO3, and nitrate has a charge of -1. Since hydrogen has a charge of 1 and nitrogen has a charge of 1, we actually don't have to do the crossing over. And we're just going to go ahead and call this HNO3. This is an example of nitric acid. Now we're going to look at sulfurous acid. Now I don't see that hydro. So again, I know I'm dealing with a polyatomic compound. So I'm looking for a polyatomic compound that's got the root of sulfur and that's got the ending of ite, right? Us means ite. So in this case, I'm looking at sulfite. Sulfite is going to be SO3. And sulfite is going to have a charge. The charge of sulfite is going to be a 2 negative. So since we have that 2 negative, we need to do that crossing over rule. That 2 is going to get written next to hydrogen. So we're going to have our hydrogen because it is an acid. We're going to write that 2 from sulfite next to it. Now remember that hydrogen always has a charge of 1, so there's actually never going to be anything written next to these polyatomic compounds. And it is aqueous because it's an acid. Hydrochloric acid, we've seen that before. Let's try to remember how to write the formula. In this case, I know it's a binary acid. So I'm not dealing with a polyatomic compound. I'm just dealing with the element that's got the root chloro. Well, the element that's got the root chloro is chlorine. So chlorine has a charge of -1. Well, chlorine has a charge of -1. Hydrogen has a charge of -1. So for hydrochloric acid, it's just going to be HCl. -1. Oh, no, sorry, not -1. Didn't mean to do that. Aqueous to tell you the state. All right, let's think about chloric acid. So chloric acid is a polyatomic compound. We know it's a polyatomic compound, an oxo acid, because it's got no hydro there. So I'm looking for a polyatomic compound that has an 8 ending because it's ic, and that has the root chloro. So I'm looking for the polyatomic compound chlorate. Well, if I look at my chart, chlorate is going to be ClO3, and chlorate has a charge of -1. So since we're a charge of -1 and +1, we don't have to worry about that crossover rule. So for chloric acid, I would just go ahead and write my H first. ClO3 after it. And I've got my aqueous. That's going to go down here. Next up, hydroiodic acid. So we know it's a binary acid. It's a binary acid because it has hydrogen in front of it. The root iodo comes from iodine. So this is going to be for the element iodine, and iodine has a -1 charge. So again, you've got hydrogen with a +1, iodine with a -1. So a hydroiodic acid would be Hi, no exchange of numbers, no crossing over because they're both 1. Aqueous down here. Hypochlorous acid, we're dealing with not hydro. Don't fall for this. This is hypo, right? So since we don't have a hydro in front, this is an example of an oxo acid. It's got a polyatomic compound in it. So we're looking for something that has the root hypochlorite. So we're going to look up what hypochlorite is. We've already seen this before. There's only so many acids we can give you. We're trying to trick you here, right? So if you actually look up the polyatomic compound for hypochlorite, you're going to see ClO with a negative. So we start with H. Chlorite or hypochlorite has a charge of negative. -1. Hydrogen has a charge of +1. So hypochlorite, we're going to not see any crossing over. So hypochlorous acid is just going to look like this. Second last, sulfuric acid. So we don't have a hydro in front. We know it's an oxo acid. So I'm looking for something that has the root sulf and then something that's got the ending -ate. So I'm looking for sulfate. If I take a look at what sulfate is in terms of the polyatomic ion, it's SO4, and it's got a charge of 2 negative. So since we actually do have a charge, remember this charge is going to end up next to hydrogen. So when I write my hydrogen, I'm going to write a 2 next to it because sulfate has a charge of 2. I'm going to have SO4. And I'm going to have aqueous because that's always a state of my acid. And last up, perchloric acid. So I don't see a hydro in front of it. Since there's no hydro, it's got to be an oxo acid. So I'm looking for something that's got the root perchlor and something that's got the ending -ate. So I'm looking for perchlorate. If I see what perchlorate is is ClO4. And it's got a charge of -1. So anything with a charge of -1, again, it's going to cross over with hydrogen, but we're not going to see anything crossing over. They're both 1, so they're going to cancel each other out. So we're going to have our hydrogen in front, and we're going to follow it up by a chlorate, ClO4. We've got that aqueous compound, perchloric acid, HCl4, AQ behind it. So that's how you name acids. Actually not that as challenging as you think, right? So remember, your decision making that you always have to do is you have to decide, is it a binary acid? Is it an oxo acid? If it's a binary acid, it's going to be hydroic acid. And if it's going to be an oxo acid, it's either ic acid or us acid, depending on the ending. So the key for this, practice makes perfect. I did give you an assignment that goes along with this. Make sure you do your assignment. The more you practice these, the more second nature it's going to be. Practice your assignment, and then after this, all you have to do is think about your unit test. Good luck. That is officially the end of the unit. Congratulations, woo, and we will see you guys again soon. Okay, so next time I see you, it's going to be Unit 2. Have a good day. See you later.